Chapter 27 introduces us to electric circuits. Now, we've already been talking a little bit about circuits because of conservation of charge. That if you have a resistor right here and you have charge going from it, the charge has to come from somewhere and has to go to somewhere. And we've been talking about that as a power supply of some sort, whether it be a battery or electronic power supply or whatever, where one side's positive, one side's negative, and we got current going through here. We introduced the idea of Ohm's law, V equals IR, in the previous chapter. Now, this chapter kind of looks at this entire circuit in a different way. Now, this is our simplest possible circuit, which is basically power supply and a resistor. So looking at this same circuit, what's really happening in a battery is that electrons are being produced and electrons are being used up in chemical reactions. And so that produces a positive charge on one plate, a negative charge on the other plate, and then electrons move this way. We define current to be a positive charge flow. So if electrons are going one way, the current is defined to be going the other direction. So electron flow and current are in opposite directions. And so that's our definition here. Long before they even knew about electrons, they knew electricity was something flowing. They didn't know what was flowing, so they simply defined current here from positive to negative. And again, positive and negative were kind of arbitrarily chosen. So this gives us the basic sort of thing. Now, what they got to thinking about, though, was that they didn't realize you were producing and using up charges in the battery. They thought somehow the battery was keeping the charges going through it, current going through it. And so clearly the energy, the electrons or the charge has more energy on this side than it does on that side. This is the negative side, that's the positive side. And so this is the positive side, that's the negative side of the resistor. So current always flows from plus to minus by definition. Okay, negative current would flow negative to positive. And so this kind of gave rise to the idea that what was happening in your power supply was it was somehow pumping the charges up to high energy. In fact, this is how you often describe electric current to people in circuits classes when they're just learning circuits, is you think of it as like an electrical pump. In fact, much of what we talk about with electric current, even the idea of electric current, goes back to water current. So they knew about water flow and pumps and pipes long before they knew about electricity. And so a lot of our terminology came from the same sort of thought process. And so the idea was that you were using a pump to pump the charges to higher energy. And so the voltage here is also called the electromotive force, or EMF. Symbol for that is kind of a script E. Now, the problem I have with this is that generally the term electromotive force is not really accurate. So it's electromotive force. That's where we get EMF. First of all, it's not a force. Secondly, it's not motive because you don't really have charges moving in so it is electro, at least. Okay. And so, but anyway, rewriting Ohm's law, V equals IR, the electromotive force, okay, it's not a force, and so it has units of volts. Okay, so it's really a potential. Okay, so the electromotive force is not a force, it is a potential. It is an increase in energy. And so we often would write Ohm's law, E equals IR. And this is how you often see this written in terms of circuits classes. E equals IR. This is Ohm's law. This is Ohm's law, just substituting the concept of EMF for voltage, and really the two are interchangeable. So there we have Ohm's law. Now, I frequently just go ahead and leave it as V instead of writing it as a script E, primarily because we're used to V already, and the other thing is we've already got E for electric field, and so rather than just confusing the whole issue, I like to just keep it as V. So you'll often see me using it as V, and the book is using it as E. At least they use it as E in this chapter. In later chapters, they're not quite as picky about that. So this is an introduction to the electromotive force and how it relates. And so, but there'll be a couple times I will use it this way when we talk about batteries and so forth. All right, so introduction to electromotive force and Ohm's law.